Hello and welcome to my lecture series for Control System 1. Myself, Sumon Ghosh, Assistant Professor from Department of Electrical Engineering, Guru Nanak Institute of Technology, Kolkata. And this lecture series is for 5th semester BTech Electrical Engineering student. And this PPT is particularly designed for lecture 7 and lecture 8. And here is the content of the lecture 7 and lecture 8. And in this video, that is lecture 7, we will discuss on block diagram representation of control system and block diagram algebra. And in lecture 8, we will discuss related workout problems using block diagram representation technique. And there will be some more problems. So moving to our first topic, that is block diagram representation. Now, what is block diagram? Now, we all know transfer function is a mathematical representation of the physical system. And to show the function performed by each component, we generally used a block diagram. And in control system consists of mathematical models. Okay, so in order to now what is block diagram reduction? Now these are all block diagrams, and what is block diagram reduction? Suppose there are multiple number of blocks and you have to analyze the system. So then you have to reduce the block and make the whole system into a single block. So it is desirable to reduce the block diagram in simple terms by means of block diagram reduction technique. So that's why block diagram reduction technique is very important. Block diagram is pictorial representation of the entire system. In this manner, it represents relationship between input and output of the entire system. Now before going to our block diagram reduction technique, here is some basic definition which you have to know for the further use of block diagram reduction technique. Okay. Now first, what is functional block? Now we all know that in control system, all the physical elements are represented by using a block. Each element of the practical system are represented by a block with its transfer function. We all know the transfer function. Transfer function is the ratio of Laplace transform of output to the Laplace transform of input when all the initial conditions are 0. Now what is output? Now first of all, what is input? Input is the excitation to the system. Now what is output? Output is defined as the product of input and gain of the system. Now what is summing point? A summing point where multiple signals are connected. Suppose a block where multiple numbers of signals are connected. That is called summing point. Now what is takeoff point? A takeoff point is a point of output. Actually, it is a point from which we can get a feedback and which goes to the input. Thus, this point will be used for feedback purpose. Now, what is forward path? The path represents direction of the signal flow is in the system from input side to the output side, which is represented by an arrow. Now what is feedback path? The path represents direction of the signal flow in the system from output side to input side. Forward path is moving from input to output, and feedback path is moving from output to input. It is the basic difference between forward path and feedback path. Okay. So, in this slide, we will discuss the closed loop transfer function. Before starting, here is some representation, that is Rs is equal to Laplace transform of the input signal. Rs means actually the reference input, and Cs is the Laplace transform of the output signal. Output means C means controlled output. Es is the Laplace transform of the error signal. Bs is the Laplace transform of the feedback signal. Gs is the forward path transfer function. Hs is the feedback path transfer function. These are the all basic representation. Now, just look at the figure. Just look at the diagram, that is closed loop diagram. Here, Cs is the multiplication of Gs and Es. Gs is the forward path transfer function and Es is the Laplace transform of the error signal. If we multiply Es and Gs, then we can get Cs, that is the closed loop transfer function. Now, what is Es? Es, just look at the figure. Es is the output of the summing point, and input of the summing point is Rs and minus Bs. As there is a negative feedback, so that's why Bs is negative. So Es is the summation of Rs and minus Bs. So we can write Es as Rs minus Bs. Now what is Bs? Bs is again multiplication of Hs and Cs. So just put the value of Bs is equal to Cs into Hs, then we can get Cs is equal to Gs into Rs minus Cs into Hs. Now if we simplify this and if we calculate the transfer function, that is the Laplace transform of output and input, output to input, where output is Cs and input is Rs. So that's why Laplace transform of the closed loop transfer function is Cs by Rs. So closed loop transfer function is Cs by Rs is equal to Gs by 1 plus Gs into Hs. This is our desired transfer function for the closed loop system. So we can write this closed loop transfer function as a block where the input is Rs and the output is Cs, and the transfer function will be Gs by 1 plus Gs into Hs. This is very important formula for closed loop transfer function. Here the feedback is negative, that is Bs is negative, but if we apply a positive feedback, then there will be a change in the closed loop transfer function. Then it will be Gs by 1 minus Gs Hs. If we apply negative feedback, then you get the closed loop transfer function as Gs by 1 plus Gs Hs, and if you apply the feedback as positive, then you get the transfer function as Gs by 1 minus Gs Hs. Just remember that. Now moving to our next slide. Here one example is given by using that previous slide transfer function. The problem is a system having loop transfer function 2 by s into s plus 1. Considering unity negative feedback, find out the closed loop transfer function. Okay, so here Gs is basically 2 by s into s plus 1, that is forward path transfer function. And here unity negative feedback is given. So the value of hs in this figure, the value of hs is 1 and the feedback sign is negative. So here is the block diagram. Just see the block diagram. Here is the block diagram. So if you apply the formula Cs by Rs is equal to Gs by 1 plus Gs Hs, where Gs is equal to 2 by S into S plus 1 and Hs is equal to unity feedback, that is 1. So if you calculate this by putting the values, then you get 2 by s square plus s plus 2, that is our desired closed loop transfer function. So it is a simple problem. Now here is some block diagram reduction rule which you have to understand, or you have to remind this type of techniques before applying the block diagram reduction technique. So first of all, blocks in series or cascade. Now if two blocks, that is G1 and G2, are connected in series, then the overall transfer function of the system will be multiplication of that two blocks, that is G1 and G2. So if we simplify the blocks which are connected in series, then you have to multiply the value of the two blocks, that is G1 into G2. If two blocks are in parallel, that is rule 2. Just look at the figure of the rule 2, first figure. Here G1, G2, G3 both are connected in parallel and connected to a summing point, and G1 is connected with a plus sign, G2 is connected with a plus sign, but G3 is connected with a negative sign. So if multiple blocks are parallel to each other, then overall value of the transfer function will be just adding of the value of the blocks. Here the value of the blocks are G1, G2 and G3, but G1 with positive sign, G2 with positive sign and G3 with negative sign. Just add the value of these three blocks, that will be G1 plus G2 minus G3. So this is the overall value of the block diagram after block diagram reduction. So if two blocks are in series, then just multiply the value of the blocks. If two blocks are in parallel, then just add them. And our next rule is elimination of feedback loop. We already see the value of the closed loop transfer function, how we calculate the transfer function of a closed loop system. So here just look at the figure of the rule 3, that is G1 and G2 are first connected in series, then you have to multiply that value of the both block, that will be G1 into G2, and there will be a feedback, that is capital H with a negative sign. Then apply the closed loop transfer function formula, that is Gs by 1 plus Gs Hs, where Gs is G1 G2 and Hs is equal to H. So after applying closed loop transfer function formula, we can get G1 G2 by 1 plus G1 G2 into H. That will be our overall transfer function of the system. Now next rule, that is rule number 4, which is associative law of the summing point. If two summing points are consecutive to each other, then you can exchange the position of the summing point. That is actually the associative law of the summing point. Next is shifting the summing point before a block. Now look at the figure of rule number 5, first figure. Here one summing point is given, that is represented by cross, and there two input is given, one from G and one from X. If we want to move the summing point before G, before the block G, then you have to multiply 1 by G with capital X. Then if we multiply 1 by G with capital X, then the overall transfer function of the system will be same as the previous one. Okay, so if you want to shift the summing point before a block, you have to multiply 1 by G. That means 1 by G means 1 by value of the block before which you want to shift. So multiply with that value with X, then the overall transfer function of the system will be same in both the cases. Now shifting the summing point after the block. Now just look at the figure in rule number 6. First figure, there is a cross sign, that is summing point. If you want to shift that summing point after G, then you have to multiply capital G, that is the block value, with capital X. Then the overall transfer function will be same. So by conclusion, in rule number 5, if you shift the summing point before a block, then you have to multiply with 1 by value of the block with capital X, and if you shift the summing point after a block, then you have to multiply the block value with capital X. Then the overall transfer function will be same. Next, shifting of the takeoff point after a block. Now what is takeoff point? Takeoff point means a point from which you take the value and send back to the input. That is, you can take a feedback from that value. That is the takeoff point. If you shift the takeoff point after a block, then you have to multiply 1 by block value with capital X. Okay, and in rule number 8, if you want to shift the takeoff point before a block, then you have to multiply with the block value with capital X. And here is rule number 9 and 10, that is shifting of takeoff point after a summing point and before a summing point. And it is very complex to do this, to apply this type of rule. So you just want to avoid this type of technique. Just look at the technique. So that's all for lecture 7. And in lecture 8, that is in our next lecture, we will discuss some problems with using block diagram reduction technique. Okay, thank you so much. Thank you for watching.